Okay, Pickering's harem. This is a horrible term. All of you in this play, this is what you would have been referred to as. This is a picture of Pickering's harem. Fleming and Cannon and Leavitt are all in that picture. And so you can see it's Pickering surrounded by a whole bunch of women. Pickering is not in the play. I think that was a wise decision. And so basically he hired all of these women to do the menial labor of actually going through all the photographic plates and circling all the stars and measuring their position and measuring their brightness, because his precious men were too valuable to waste their time doing that kind of thing. William Enoch Fleming was the first one hired. There is a legend, I don't know how true it is, that basically Pickering was kind of a bully, and he was really mad at a grad student one day, and he didn't like the job the grad student was doing, and he said, my housekeeper could do a better job than you, which she was his housekeeper, and then he hired her to come work for him. And so she was the first one, and once she started working for him, he realized, oh, women can do things. And so then he started hiring more women because women are cheap labor. And so she was the first one to come up with a system to catalog the stars. She cataloged hundreds of thousands of them. Then Annie Jump Cannon comes along, and she made the next big insight, which was that the hydrogen lines correspond to the temperature of the star. So the strength of your hydrogen corresponds to the temperature of your star. And so she reorganized the classification system. And so it's because of her that we have that OBA order that we still use today. And she got rid of a lot of classes because she realized they were really just like subclasses of the same class. And so now we're down to 7 solar types. And then of course, Henrietta Leavitt was the next person to come along, and she devised the first way to measure very far distances. Prior to this, astronomy was all stars. After that, astronomy opened up, and you now had the field of galactic astronomy. Let's talk about Celia Payne. Celia Payne was also working around this time. She wrote her thesis in 1925. It is widely considered to be the most important thesis ever written in astronomy because it determined that the sun is made of hydrogen. The leading theory of how planets were formed at this time was that they were formed from material strewn out from the sun by a nearby passing star. That's not how they're formed. But because the Earth is mostly carbon and iron, it was assumed that the sun would be carbon and iron. And so when she said that the sun is made of hydrogen, her advisor was like, you can't publish this. You will be laughed out of town. This cannot possibly be correct. And so he didn't believe her results. And so her advisor was Henry Norris Russell. His name is in every astronomy textbook that there is, because we have a famous diagram that we use for stars. It's named after him. It took him 4 years later to convince himself that this was true and that she was correct. And so he published the paper, the very famous paper now, that says that the sun is made of hydrogen, and she is a mere footnote in that paper. So her thesis isn't even properly cited. So next, Jocelyn Bell. Jocelyn Bell, if you bring up the name Jocelyn Bell to most astronomers, they will be infuriated because of what happened to her. Okay. So she used this telescope that you see right here. It's the Jodrell Bank telescope in England to discover pulsars. Neutron stars are very massive stars that have exploded, and it's what's left at the core is called a neutron star. They were already hypothesized to exist, but it was assumed that you wouldn't actually be able to observe them because they wouldn't have glowed very brightly. So she was observing one night, and she noticed this weird glitch in her radio data. So there's a lot of noise in radio signals. So she brought this weird signal, this weird like repeating signal, to her advisor, Anthony Hewish, and he was like, well, this is garbage. It's just a noise that you just haven't figured out what it is yet. I'm not interested in this. Don't talk to me about this. And she persisted, and she ruled out all the possible sources of noise, and she was able to prove that this was coming from space. They didn't know what it was at first. It was called like the little green men. And then eventually they figured out it was a pulsar, which a pulsar is a really fast type of rotating neutron stars. At that point in time, once he realized what she had, he cut her out of all meetings and it was him and his male collaborators who worked on this project. He was nice enough to put her as second author on the paper, but he went on to win the Nobel Prize because this was an incredibly important discovery. He won it, she did not, even though she is second author on the paper. So that's two forms of sexism. That's sexism by him and it's sexism by the Nobel Committee. However, she has gone on to have an illustrious career. She's now a dame. She has been awarded tons and tons of prizes. She's awarded the 2018 Breakthrough Prize in Fundamental Physics, for which she got $3 million, which is more than you get for the Nobel. Vera Rubin. Vera Rubin is also the person that makes astronomers the maddest, okay? Because she provided the first evidence for dark matter. If it weren't for her, we wouldn't understand cosmology today, right? If dark matter makes up 75% of the matter in the universe, or more than that. And she was the one who first proved this by looking at galaxy rotation curves. So her career is also quite interesting. She wanted to go to Princeton, but Princeton didn't accept women into their astronomy department. Long after the university started letting women in, the astronomy department was like, eh. And it wasn't until like 1975 that they started letting women in. And she needed to use a telescope for her studies, and Palomar didn't let women observe there still. Like, we're talking about the 50s and the 60s, and she's dealing with the same stuff that these women back in the 1900s were dealing with. So she got approved to observe at Palomar, but one of the reasons was given that she couldn't use there is because there's no women's restroom there. And so what she did was she just basically took a sign and she slapped it over the restroom door and said women's, and she's like, now there's a women's restroom. She just got honored by being on a US quarter, and she never won a Nobel. And now she's dead, and you can't win a Nobel if you're dead. This is considered the largest snub in Nobel history because what she did was so fundamental. And not only did she not get the Nobel, literally the year after she died, they did award a Nobel Prize for dark matter. They were just sitting on it, right? You have to award a Nobel Prize for dark matter. They just waited until she died. All right, so next I'm going to tell you about some female astronomers who are still actively working in the field today. This is Andrea Ghez. She is a professor at UCLA. Her fundamental contribution was that she proved that our galaxy has a supermassive black hole in it. So it is because of women like her that I get to do the work I do, because I look for supermassive black holes. This was a big race back in the 1990s, and so there were two competing groups. There was her group, and then there was the much more well-established Reinhard Genzel. And basically, they published papers around the same time. So they shared the Nobel because they had both proved that there is a black hole at the center. He went and made public comments to the media about how she only won because the Nobel Committee needed to give it to a woman. And so that's why she was included. Okay, yeah, pretty gross. Okay, next. Daniela was one of my mentors when I was in graduate school. She is a member of the National Academy of Sciences, which is incredibly prestigious. So she derived an equation for dust in the Milky Way to show how it dims light from stars if you've got dust between you and the star. It's called the Calzetti dust law. It is widely used in the field. It has been, that paper has been cited over 5,000 times. Her favorite thing to tell us is that anytime someone meets her and they've never met her before, they ask if she's related to the person who came up with the Calzetti dust law, if that's her brother or her husband. All of this is to illustrate that the people that you're playing essentially still exist in some form today. That this is not a problem that's gone away. If I can offer one piece of advice, it's how you're thinking about these characters. This play is really joyous and it's full of a lot of hope and discovery, and that is certainly one part of my job. I love what I do. Science is really cool. All of the women I showed you have made huge discoveries that were just amazing and delighted them. The other part of working in this field is the weight you feel on you, knowing that everything is twice as hard for you, and thinking of all of the bad things that have happened to you, the way that you've watched men have access to telescopes, get paid more, get these more prestigious positions, get more citations, all of these things. And so I would imagine that these women feel that weight in the same way that we do.